Now we've already talked a little bit about function notation, but let's talk about the definition now. Mathematicians are famously lazy. We don't want to have to write evaluate the function given by blah 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 every time we want to use it. And so to get around writing all of this, we use symbols to represent all those words in a much more efficient manner. In order to use this new efficient notation, we need to have three things. We'll want a name, usually a single letter such as F for function, to avoid too much confusion, but we can use other letters if we want. We need something to represent our input. This is a placeholder variable. Often we use X, but we can use other letters as well. And then finally, we need some algebraic expression that represents what the function is actually doing. For example, is it tripling our input? Is it taking the square root of our input? Is it doing some exponent with our input? And these three things together define our function notation. Now, when we want to plug in a specific input, we replace our placeholder variable with that number. So remember, we said our placeholder is usually this x right here, and it also occurs in the algebraic expression. F of our input x is 2 times x plus 3. So if we want to evaluate this function at the input 2, every single place we see an x, we're going to replace it with a 2. F of 2 is not 2x minus 3, but rather 2 times 2 minus 3. 2 times 2 is, of course, 4, so this simplifies to 4 minus 3, or just 1. We can write this whole thing out in just a single line as f of 2 equals 1. Now the important part here is that the thing in the parentheses is our input. So our input, what we plug in, is 2, and our output is 1. If we were to try this with another number, let's say 5, f of 5 would be 2 times 5 minus 3. That works out to 10 minus 3, or just 7. When our input is 5, our output is 7. And again, we could evaluate this function at any input number we want. Let's do a couple examples. Say we have a function g of x equals 5x minus 7. Our input variable, or our placeholder variable, is x, and we want to look at what happens when we evaluate this function at the point x equals 2. That means anytime we see an x, we're going to replace it with the number 2. So we could write g of 2 is 5 times 2 minus 7. That is, of course, 10 minus 7, or just 3. G of 2 equals 3. This is the same process when we have a negative number. For g of negative 6, we'll start by anytime we see an x, we'll replace it with negative 6. G of negative 6 equals 5 times negative 6 minus 7. This is negative 30 minus 7, or just negative 37. When our input is negative 6, our output is negative 37.